Okay, welcome. This is one of three science videos. It's the first one. This is Science Video 401 for the ACT. So I'll just say Science 401. And this video is all about how to. So what types of passages will you see? How should you go about reading them? How much time will you have on each passage? How should you divide your time between the material presented in the questions? This will be a relatively brief video, but we'll go through all of that. So first, let's just start with the timing. A lot of students say, hey, I could probably get every question right on the science if you just got rid of the time limit, because the science is actually very straightforward and it's not difficult, although the bark is worse than the bite. So you'll see concepts you've never heard of. One we'll talk about in a moment will be telomeres. Some of you may have heard of that, but a lot of people will have never heard of telomeres. They have to do with kind of the caps at the end of your chromosomes. But anyway, you'll see they could test you on anything from like de-icers and things that have to do with concrete. They could test you on environmental sciences. The topics are vast. However, they will always give you everything you need, and you won't need a lot of background knowledge beyond kind of what you learned up to the age of maybe 12 or 13 in science. So the background knowledge is not that deep, so you don't have to worry about that. Maybe only out of 40 questions, maybe like 4 really require some background knowledge. And those questions are usually fairly basic. So maybe understanding that density is just mass divided by volume. So they may not tell you that, but they may just kind of want you to understand that that's what density is. Basic things like that. So anyway, let's talk about the timing of the science first. Then we'll talk about kind of how to divide your time between the tables and the charts and the questions. And then we'll talk about the different types of science passages. And then kind of after we lay out this how-to, then science videos 402 and 403 will actually go through practice where we can do some of that together. But let's just cover the how-to on this. So as far as timing goes, so you're going to have 6 passages. If you look at any test before 2015 and even some versions of 2015 ACTs, you have 7 passages. That's changed. The ACT decided that 7 passages to cover in 35 minutes was too many. You only had 5 minutes a passage. In their great generosity, they said, okay, 6 passages, no longer 7. So 6 passages, 35 minutes. So if you do the math, that's roughly under 6 minutes a passage. That's not a lot of time. I think the mistake that a lot of people make is to go straight into the questions. I'd actually advise you not to. Out of the roughly 6 minutes a passage, I would spend a minute to a minute 30, I'll say 1 to 2 minutes, canvassing the information before you actually go into the passage. What's the information that you'll see? Well, you'll get a brief so out of 6 passages, 5 passages are just going to be kind of experiments, traditional experiments. One of the passages will be competing hypotheses, and we'll talk about how to do both. But let's do this one on the left first. Okay. So the 5 passages that are experiments, they just want to make sure you understand the basics of how an experiment is set up and how the scientific method works. So as you're taking that minute to minute and a half, maybe 2 minutes max, what you're going to see is you're going to see an introduction where they kind of briefly tell you something we already know. So let's just pretend the passage that we get is about plant growth, okay? We're trying to maximize tomato and let's say spinach production. So if we're trying to maximize tomato and spinach production, they may tell you, hey, we figured out that nitrogen and phosphorus tend to expedite and speed up plant growth. So they'll just give you that background. They'll say, hey, nitrogen, phosphorus, great for plant growth. But what these scientists have set out to do is they're setting out to figure out how much nitrogen to use for both spinach and tomatoes, how much phosphorus to use for both spinach and tomatoes, and which one is kind of the better chemical for the growth of each one. So what they'll do is they may run a very simple experiment where experiment 1 will be with just tomatoes. And what they'll do is they'll have a control group where that one gets no nitrogen or phosphorus, so control. So no nitro or phos. Then what they'll do is they'll have a group that gets varying levels of nitrogen. So I don't know what the right amount is. The unit almost doesn't matter, but we'll say like 5 milligrams of nitrogen per plant. And I apologize if that's not the right level. 10 milligrams of nitrogen per plant, and so on. And then also they'll do the same for phosphorus. So, same thing for nitrogen and phosphorus. So they'll have the control that gets neither, and then they'll run nitrogen and phosphorus. And then maybe even they'll do a combination of both. All you need to do when you look at the graph or the chart that kind of displays it is you just need to think about what's being measured, what's my input, and what's my output. So in this case, your input is what type of fertilizer you're using, right? What type of chemical you're using in your fertilizer. And then your input is also the amount. So it's the chemical and the amount. Your output, they may say something like plant yield. They'll take something very basic and they'll come up with a word that's scientific for it. Plant yield could be something like, the weighted mass of all tomatoes per, I don't know, given area, per hectare, who knows. But they'll do plant yield, so mass per hectare. And what essentially all you're doing, and again, it's taking me a long time to talk about this, but on the actual thing, you're taking about maybe 20 seconds to say, okay, my inputs are nitrogen, my inputs are phosphorus, I'm inputting different amounts. Great. Okay, so those are my inputs. Okay, let me quickly look at my outputs. Okay, so what I see is as I add more nitrogen, my output goes up to a certain amount, and then it kind of levels off. All right, phosphorus. I add, my output goes up to a certain amount, and then there's a point of diminishing returns and then no returns on the phosphorus. So that's something that you just kind of want to be aware of is how your inputs influence your output. And then, so that may be experiment 1. And then the second experiment, and they'll give you a table or a chart with that experiment. So the second experiment, experiment 2, experiment spinach, they'll do the same exact thing with the nitrogen and the phosphorus, and the control group, they'll just run it with spinach. So here's the key thing on these passages. You want to make a careful note of what's being measured on each. What are your input variables or your independent variables? What are your outputs or your dependent variables that are influenced by your inputs? And just a brief idea of how they're related, very brief before you go into the questions. So that's kind of what you're doing. You're taking a minute to a minute and a half to canvas kind of the introduction. What's the background? Nitrogen and phosphorus are generally good for plant growth. Then you're just seeing the experiments, how these inputs influence the plant yield on these different plants. And then the other thing you're paying close attention to is what changes from experiment to experiment. So in this case, what we changed is we just swapped out tomatoes for spinach. As you go into the questions, you'll have about 6 questions. And what the questions do is they tend to go in order of difficulty within the passage. The first 2 to 3 questions are just usually you just finding data in the chart. So it will say, hey, when there's an output of, 10 kilograms per hectare of tomatoes, or let's actually say 22 kilograms per hectare of tomatoes, what was the input? So what was the input of phosphorus? So they say, what input of phosphorus will yield this output? And you'll just look at the chart and find it. So those are the first couple ones. And all of this will also make a lot more sense in video 402, where we actually do it. But yeah, the first few are just warm-ups. And then they may even ask you a most likely question, which is a data inference one. So they may say, hey, and we know the experimenters didn't do it, but if the experimenters used maybe 30 milligrams of phosphorus per plant, what would the output have most likely have been? And you'll realize that, okay, it goes up and up and up, my output of plant yield, as I use more and more milligrams until it kind of levels off. So you'll see where it levels off, and then you'll just say, okay, that's the output. Again, I know this probably feels pretty abstract. This will make a lot more sense in 402. The last few questions tend to be a little bit harder. They sometimes require you to reference multiple charts, and sometimes they require a little bit of basic background. But that's essentially how the 5 passages on experiments work. Just understand your independent variables and understand how they impact your dependent variables. About 1 to 2 minutes just kind of canvassing, and then the rest of the time, 4 minutes or so on the actual questions themselves. Okay, so the other type that you have is competing hypotheses. And for competing hypotheses, what you want to do is they actually don't run the experiment usually on these. And let me kind of clear a lot of this off. What the competing hypotheses will do, I'll just clear it all off. What the competing hypotheses will do is they'll have maybe 2 students or 3 students or 2 scientists or 3 scientists, and they'll explain something we already know about. So the example they may give is they may, and then each student or scientist will have a different hypothesis for why the phenomenon occurs. So they may say, hey, we know that adults age. We know that adults age. And for a while, we think that the aging of adults, scientists have kind of been able to link that to our DNA and the replication of cells. So DNA and cell reproduction results in aging. What scientists don't agree on is what within the DNA and cell reproduction actually causes the aging, right? That's misspelled, aging. There we go. So anyway, which one is it? That's going to annoy me. Oh, either one. Let's see. Both are correct. There you go. I was worried that I was screwing it up on the video. Either way, you can spell aging either way. So I shouldn't have crossed off that first one. Anyway, so they'll be debating essentially, what actually causes aging. And on this one, it's kind of more like the reading section, in that you just want to understand what the scientist's hypothesis is and how they're the same and how they differ. So scientists 1 may say that aging is caused by the shortening of telomeres. And scientists 1, they'll tell you what telomeres are. So scientists 1 will say, hey, telomeres, they're these caps at the end of our chromosome strands. And what they do is they kind of maintain the integrity of the chromosomes and the genetics within the chromosomes. And what happens is, as cells reproduce, we lose more and more telomeres. The telomeres shorten, and then that leads to the degradation of our DNA, which leads to aging. So that could be the telomere one. And then scientists 2 may say, yes, that is true that telomeres do shorten over time, but they don't shorten enough over time, a human's lifetime, for it to really have any significant impact. Scientists 2 may say, actually, although I acknowledge that telomeres shorten over time, and that could be problematic if humans live for 400 years, what actually causes the damage are environmental factors like carcinogens. So it's not telomeres that cause aging, it's carcinogens that cause the degradation of cells, and then that causes aging. So it's, the oxidation of the cells and just exposure to free radicals and other things. So the key thing you want to do is you just want to understand what's the phenomenon that these scientists are trying to explain, and then how do they differ, how are they the same? And usually the first sentence of each scientist's blurb will state exactly what their position is. And then within the paragraph, they'll kind of give points to support their position. But usually the first or last sentence will make very clear what their position is. So you want to pay a lot of attention to the first and last sentence. Okay. This video may feel a little bit confusing. I know there's a lot of words and not actually much data in front of you. So watch videos 402 and 403 to see how we apply all of this. Anyway, I hope this is helpful, just kind of giving a general idea of how to do the science. And please come back for the other two videos.